Hello, everyone, and welcome to Sink or Swim, the challenge of complex offline apps. Please allow me to introduce myself. My name is Bruno Martinho, and my role at OutSystems is front-end and mobile expert. My goal for this webinar is to be able to share with you all how to address the complexity of offline apps. Currently, internet access is available in almost every place, in such a way that sometimes is taken for granted. But actually, there are still a lot of cases where simply you cannot have internet and it doesn't need to be in a raft in the middle of the ocean. I believe calling a water Hoover is out of the picture for this one. A quick note, if you haven't attended his webinar, I advise you to see it and follow Ricardo Ferreira from our R&D team and start building your offline app with OutSystems. All right, so you have decided to develop offline apps. So you are aware that things might get complicated. So you know that now it's time to sink or swim. Piece of advice, be prepared. Okay, so let's talk about designing offline apps. Remember to measure twice, cut once. Executing great tasks requires an even bigger preparation. So for an app to go offline, we need to think offline first. We can divide it in two areas, thinking features and thinking data. The features that a app will have offline are necessarily different from the online features. A simple example to show this is a mobile app with a real-time chat that cannot work offline. Sometimes it's necessary to step back and look at the feature and make the question, does this make sense when the app is offline? This can avoid wasting time and resources in solutions that simply won't work. Regarding thinking data, you can see that data is highlighting, meaning that we'll be focusing on this. Generally, statements doesn't make us think too much, but questions will. So 3 questions need to be answered. What, when, and how. It's necessary to define what data must be synced with the device. This definition should be made in terms of scope. An example, only orders to be fulfilled by a logged user should be synced. In terms of range, it should be defined a time range for the data. Only data in the last month should be synced for history purpose, for example. There are a few common pitfalls that we need to be aware. Trying to sync all data from all users since the beginning of times can be destructive for the app. If it doesn't make sense to compare a mobile device to a dedicated database server, probably they shouldn't carry the same data, right? Another pitfall? Yes, not a typo. So business will pressure you a lot of times for these requirements. So this matter will be on the table often. You need to address it. Other question to be answered is when should the data be synced? Data can be synced from device to server, server to device, or both ways. It is possible to sync on login every time you're offline and change to online, or even require a user action to do it. All depends on the business logic. Another important topic is that different entities might have different requirements. An example, reference tables like a country list don't need to be synced every time. In this case, the most common pitfall is to try to sync all data every time. So this can cause the sync process to be slow and some performance issues. The how question is related to the way data is managed in terms of reading and writing to the server. This is possibly one of the most complex subjects, and we will address it details in this webinar. Please keep in mind that there are no silver bullets because this is a very complex subject. Business requirements are so different that proposing one-size-fits-all approach isn't possible. Here is the list of 5 of the use patterns that are implemented and well documented. Read-only, read-only optimized, ReadWrite Last Wins, ReadWrite conflict resolution, and ReadWrite OnetoMany. So the solution for each case can be one of these patterns, more than one, or even none. If we were measuring twice and cutting once, in this case we should follow the Russian version, Measure 7 times before cutting. So let's deep dive in the OutSystems platform syncing mechanism. We're not going Ron Swanson and you guys here. We're actually going to teach you how to fish in deep waters of offline. That's why it's so important to stick to understanding the logic. Other than documentation we mentioned before, we'll also have the code for you to play with, available after. So how to set up offline? It's easy. We just need to create a mobile app on our Service Studio, and the offline will already be there. So when a mobile application is created, automatically you have access to a block to manage the sync events, client actions for synchronization, server actions, and local storage entities to create data inside the devices. So let's look how does the sync process works. Let's look at that y-axis that represents time. Everything starts by triggering a client action to start the synchronization. This will raise an event stating that the sync process has started. Then, a call to a server action is done asynchronously, which means that it's possible to keep using the app. The server will process the synchronization, and then the response is returned to the client action that will do whatever necessary in the device database. And finally, the end or error event is raised, showing that the sync process is over. To control the sync process, there is a block that is automatically placed inside the layout that raises 3 events. This information is right here just for your reference, so we can proceed. These are the configurable settings of the synchronization. You can find them on the platform's online documentation. So there are also actions that we use to actually sync data to the server. The important part here is a common pitfall that is when we need to manually start a synchronization process, sometimes we use offline data sync instead of trigger offline data sync. So trigger offline data sync should be used because this is what will allow the process to be asynchronous, and that is the behavior that we desire. On the server action, it is necessary to implement the logic to synchronize the entities in the service database. These actions should be protected, validating if the user is registered for security reasons. So we should not allow unregistered or anonymous users to make synchronizations to the server. Okay, let's talk about the 5 patterns that are most common. Once again, keep in mind, no silver bullets and no one-size-fits-all. These are just sample patterns to help us understand how to apply this in your very own case. Okay, so the list of our 5 data patterns. We have read-only, read-only optimized, ReadWrite Last Wins, ReadWrite conflict resolution, and ReadWrite one-to-many. In the first 2, data will flow from server to the devices, so it will be an unidirectional data flow. In the remaining ones, the data will flow in both directions, and you can be syncing the information that's on the device into the server. To help explaining each pattern, we are now featuring some well-known sink or swim experts. Unfortunately, more swimming than thinking. So we'll start with Robinson Crusoe, probably one of the biggest castaways in history. Chuck Nolan from Castaway movie, if you remember. And also we'll have with us Jack. Okay, Jack Sparrow, not Titanic Jack, because that one, I don't believe he was very good at swimming. Okay, so let's continue. We'll have, you can, on the end of this webinar, you can download from the OutSystems Forge this application that has all of the information regarding these patterns where you can look at the code. So I'll use it as a reference here. Okay, in the end, you will have the link that you can follow. Okay, let's start. So the first one we're going to approach is the read-only data. Okay, this one is recommended for mobile apps where end users only need to read data while the apps are offline and the amount of data is small. If you see on the image, the information will only flow from the server to the mobile device. So the local database doesn't send any data to the server. The server data is always master. And an example of this is a product catalog app where, for example, Salesforce can have the information on a tablet and show it to customers without having internet. Service Studio has an accelerator for this. So if you have a local entity, you just need to right-click and then select the options to create the action to sync data read-only. So all of this logic that you see next will be created automatically for you. Let's try to understand a little bit better the process instead of looking at the code. So what happens right now in this situation is that we have inside the mobile device in his own database two castaways. So Robinson Crusoe here is Chuck Nolan. And if you see, someone has already updated the server, and we have Robinson Crusoe, Chuck Nolan, and Jack Sparrow here. So to make this read-only data, let's look at the process. The first thing we need to do is to get data from the server. So all the information will be gathered and sent back to the device. Now on the device, what we need to do is to delete all the data from the local device. And after that, we will write everything that we received from the server. So this one is a very pretty simple process that mainly what's doing is removing everything that you have and refreshing the information with the information from the server. I've put some examples here of the code. Okay, we won't take too much long time looking at this, but it serves as reference for you after this webinar to go back to this information and look at it more carefully. So the next one will be read-only data optimized. Read data optimized is recommended for mobile apps where end users only need to read data while the apps are offline and the amount of data is small. So you can see that the information that is sent from the mobile device to the server, it's just the last sync date. So it's just a small timestamp. And the server will send the sync data to the device. So the local database will only send the timestamps to the server. Again, server data is master, and the advantage is that it will download less information from the server because it will just send the data that was changed after the last sync date. To achieve this, we need to change a little bit the server entity data model. So we'll need to have a new column that has the last update date of that record and also a field to do a soft delete. This is very important because if we delete things in the server, if we don't soft delete them, there is no way we can tell the device also to delete that record from its own database. Again, let's look at the process. So in this use case here, we have already Robinson Crusoe, but only Crusoe, okay, on the database of the device, Chuck Nolan and Jack Sparrow. And if we see on the server, we have Robinson, so not Crusoe, Robinson, that was modified today. Chuck Nolan has been modified 1 week ago, and Jack Sparrow has been deleted today. If you see column active, it stands here for our soft delete field. So let's look at the process. So the first thing is we're going to need to get the device last sync date. Typically, this is stored in a local storage table. So we're going to query the table and get the date. So we can see that in the example, the last sync date was yesterday. Next thing will be the get modified and deleted data in the server since the last sync date. So let's look. So after yesterday, Robinson was updated because it was modified today. Chuck Nolan 1 week ago, nothing happens. And Jack Sparrow, he was soft deleted today. So this one will be marked for update and this one will be marked to delete. Next step will be to insert or update the modified data in the device. Probably this was a little bit fast, so we can do a little go back, and you can see that Crusoe has now changed to Robinson. Next step will be to delete in the device the deleted rows in the server. So Jack Sparrow is a good candidate to be deleted because he was deleted on the server. And then the final step should be update the last sync date. See that the date is now set to this current instance. What happens now if we run again the same process and we follow these 5 steps, we will see that no data will be synced to the server because everything is already synced. So this will be optimized. If we were on the previous case, we would delete everything and recreate again the table. Again, we have here the code, so you can see exactly in the flows where we are doing each part of the process, okay? And let's jump now to the read-write last win. So here is where things are going to be a little bit more complex because now the information is flowing in both directions, and we need to understand how we're going to address this. So in this case, the ReadWrite Last Win is recommended for mobile apps where it's not likely for multiple end users to change the same data while the app is online. Let's look at this scheme here and understand that from the server, information A is sent to both devices, but this device is going to change the information and send back the information A1 to the server. So A will become A1. What happens is next, this device 2 has received A, but you will change in a different way, writing back A2. So if you see A1 will be replaced by A2. So what happens in this case is that the local database changes and it sends the data to the server. The data in the server is always overridable. This is very important. And as an example of this, we can have field services apps where different users can access information in a work order, for example, and be changing some fields there. So this one, like the first that we've seen, also has an accelerator in the Service Studio. So if you want to do this sync data read-write last wins, all you need to do is right-click on the entity and select the create actions, and all of the logic and the flows will be automatically created. Nothing better than looking at an example to understand how the process works. If you see on the database on the mobile device, we have now created for the same entity 3 new fields. This one server is stating if the record had origin on the server or not. Being false means that this row has been created in the device and not on the server. Okay, so it only exists locally in this device for now. Modified, it means if the data has been modified since it was reserved from the server, and active is the same field as the soft delete that we've talked in the previous case, but now on the device and not on the server. Looking at this example, okay, so we have Robinson in the first row and here Crusoe, so we can see that they're different. Chuck Nolan exists on both sides, and Jack Sparrow only exists on the mobile, so not on the server. If you see server, it comes from false. Now let's look how things are going. So the first thing is to check the local data for new, updated, and delete data. So if you can see, Robinson has been updated because it has been modified. Chuck Nolan, since as active as false, it has been deleted. And Jack Sparrow, well, he didn't come from the server, so he will be a new one. Next step will be send information to the server, and on the server side, we need to create, update, and delete data. So probably this was a little quick step. Let's take a look. So Crusoe will change to Robinson, okay? Chuck Nolan, he's going to be deleted. And Jack Sparrow, well, he wasn't there, and now he is. Okay, but now we need to close the loop, okay? Because we need to get all the data again from the server that was synced. In this case, what we're going to do is we're going to delete all the data in the device after receiving the data from the server. And after that, we're going to write all the data from the server. Please notice here that the IDs will remain the same as the ones that we have in the server. So this will allow us to make a direct mapping between our entities on the device and the entities that we have registered on the server. So this is also, as you can see, the flow are starting to get a little bit more complicated, but yeah, they're not as that complicated. So I think this will be pretty easy to follow. Okay, so next pattern will be read-write with conflict detection. This is a little bit more complex one. Okay, so this is recommended for some advanced scenarios where multiple end users will change the same data while the apps are offline. So in this case, what happens is that information A will be sent to both devices. Each device will change as they want. So this first one will change to A1, the second one will change to A2, and they will sync back the data for the server. And now in the other case, we were overriding information, but in this case, so A is no longer A, but we need to decide what happens. Does it change to A1? Does it change to A2? What should we do here? So the local database changes and sends the data to the server. So the data in the server has a conflict and needs to be resolved. An example for these applications are, for example, field services apps where we have collaboration. So this is very important because we need to make sure that the information that's being written on the application is the correct one and the most recent one or the right one. So this depends a lot on the business logic. So this is different because we will need to, on the devices or somewhere, to define a conflict resolution strategy. Okay, so let's look how we're going to do things here again. In this case, you can see that the structure on the device has these 3 new columns, and on the server also we'll have the 2 columns. So it's kind of a mix of the other scenarios that we've seen so far. So let's just look at the data, analyze a little bit before we start the process. Okay, Robinson, what happens here Robinson came from the server, but it was changed, okay? And in the server, this was changed yesterday, okay, to Crusoe. Okay, Chuck Nolan, what happens is that he was changed on the server 1 year ago, so nothing, no news for Chuck. In terms of Jack Sparrow, you can see that it didn't come from server, so he will be a new one and it doesn't exist in server. Okay, one important thing in this process is that we should only allow the sync of the information if no data in the device is marked as a conflict. It doesn't make sense to be trying to synchronize data if there are conflicts in the device without being solved. Okay, the first thing is to get the last sync date from the device. In this case, on this example, we will use 1 month. So this was a device that was 1 month off the grid and is now trying to sync data. We're going to look at the device for the new update and delete. So Robinson was updated, Chuck Nolan was deleted, and Jack Sparrow is a new one. The next, is we're going to send this information to the server, and we'll do only first the create new data. So this was a little quick, so let me try to go back. So if you see Jack Sparrow, nothing changed except Jack Sparrow was created. After this, we're going to update the rows that have modified date before our last synchronization. The others will be marked as conflict. What does this mean? So our last sync data has been 1 month. If you're going to see here, for example, Crusoe, he will be updated, right? But his modified date was yesterday. So yesterday is after 1 month that we have. So it has already changed in the server after we've changed in our application. So, or not an application, sorry, when we synchronize. So this will mark here as red as a conflict. Next, we're going to delete the rows with modified date before the last sync. All of the others will mark as conflict. So the idea is the same. Is always mark things that have been changed after our last synchronization date. But in this case, Chuck Nolan was changed a year ago. So a year is before 1 month, so we can delete it anyway. Okay, next step will be to return from the server the last sync date. You can see this will be now, and 2 lists. One, the list with conflicts, and other with no conflicts. So the ones that are in a conflict should be added in a conflict table. So another table should be created that will store the information. If you see, Crusoe came from the server, but we will be putting here a little bit on the side in this conflict table. Next step will be delete everything from the local table, and next we should write the data on the device received from the server except for conflict. For the conflict, we will keep what we already have in the device. So let's look at what happened here, and we can see that we had Robinson on the device, and we had Jack Nolan and Jack Sparrow. So we deleted everything, and now Jack Sparrow was received from the server and is here, but Crusoe was received from the server, so but since he has a conflict, we will keep writing Robinson in our table. So we won't change anything because there's a conflict that needs to be addressed. So we're going to update the last sync date to now because this is what we've done. So we've synced, and now a very important part that will be show conflicts to solve. So right now, what happens is that we have information on the device that is not synced with the server. There's a conflict here, and we need to solve it. So what I'm going to do right now is I'm going to demo you how can we build this process for doing the conflict resolution. So bear with me a little bit because I'm going to show you this on Service Studio. Okay. First thing I'm going to show you is the app that we're using. Okay, for castaways. Okay, so this is an app that's very helpful for someone that's a castaway. Okay, because they can pick their seat on a lifeboat. Okay, since they're in an abandoned island, they have no network. Okay, but they can work offline because this app is very good and it works offline. So Chuck Nolan is currently on the island and he's already thinking, well, when I'm safe, I probably want to go on this side. I always like to go on the left side of life rafts. So imagine that the boat passes and the boat actually has Wi-Fi and is giving him the Wi-Fi signal, so he becomes online. So what happens is that the conflict has been detected and must be resolved. Okay, so this means that on the server, Crusoe already has the information that he wants that seat, so we need to solve this conflict. Okay. Let's look how in our Service Studio are we going to do this. First of all, we'll keep in mind how things work in terms of the structure of our database, and let's see how can we implement the code that will allow us to do this conflict resolution. The first thing that we need to do is, well, we have to create a screen. I've already done this, so I wouldn't take too much time here. That you've seen that this is the screen to resolve a conflict. Whenever we resolve a conflict, we have to choose between the information from the device and the information from the server. So Robinson here is the information that, sorry, in this case, Chuck Nolan is the information that we have on the device, and Robinson is the information that we have on the server. We should always have two actions to solve this. One should be, well, we call it keep mine, but it means that I will keep the information that we have on the device, and the keep server, it means that we're going to keep the information that we have on the server. So we can start with keep mine because keep mine is the one that's more simple. If you see, there's a conflict table here and the information that we have in our local database. Okay, so we have, let's just look here at the data. So we have a local seat. It's a very simple one that only has the place and the name of the person on the seat. And if you see, it's very simple. If we want to keep ours, the only thing that we need to do is go and delete the information on the conflict table because we know that there's no conflict. What we have in our device is what we want to keep. So we'll just go here and delete the conflict. Okay, so this one is pretty straightforward. So the only thing we need to do is go here and we can delete the local conflict. Okay. And after that, well, it's always nice to say something to the user. And let's say, don't worry, your seat is reserved. And after this, we can send again to our home screen. So this one is a pretty simple one. So let's look at now at the keep server. Okay, so to do this, to do the keep server, what we need to do is, and let's look at the information first that we have, is the correct information that we want to keep is the one from the server, and we have that information here in the table of the conflict. So what we have to do is get this table, get this row, sorry, and just put the correct information in our row. So the first thing we're going to do is we're going to create here. Okay, we have a local seat. Okay, we're going to say that the seat ID is the one that we received. The index. Now the index, if we see we have a query to go get the local conflict, so we're going to go here and we need to go to our conflict and say that the index is the index that is on the conflict. We'll do the same for the name. And okay, so the information, let's just put this here, override seat, so it's easy to read the code. So what we need to do right now is to update not the conflict, but the seat, okay? We're gonna put the local seat, okay? So we have updated this information, but now also we need to remove the information from here because we already don't solve the conflict and we don't need this information here. So we're gonna go to the local conflict, and in this case, we can even delete, well, we can delete all the conflicts, and let's send a message to the user so that the user know what happened. So in this case, what happened is your seat has already been reserved. Please choose another one. And let's send this back to the home screen. Okay, so now we can publish. And after we publish, let's test and see if our synchronization conflict resolution is working. Okay, so let's restart the application. Okay, the application has been updated with the latest code, so we're okay. Okay, so check Nolan, he's on the island again, and he's picking the spots. Maybe this one or that one. Well, let's stick to this one. Okay, and okay, the boat with Wi-Fi is passing by, so he now has network. So the conflict has been detected and must be solved. So if we click on Chuck, what happens is that we'll keep ours, and if we click on Robinson, we will keep the server. Chuck is not going to let Robinson get out of the boat. So he will give him a spot. Okay, so we will choose Robinson. Now let's see what happens is that, okay, so your seat has already been reserved. Choose another seat. So what happens is that the data was synchronized after we synchronized to the server. It synchronized the information on the local device, and Robinson is already here. If you check, we have put it all again offline. So this is reading data from the local storage. So since this one is occupied, you'll get this one put here, and now that the boat is going to pass again, and okay, the seat is reversed, you will be saved. So this shows how we can set up the logic to resolve the conflicts. Okay, I think we can proceed now. So for this read-write with conflict detection, okay, you can see here also the logic. Okay, we made it. So what we did the conflict resolution. So this is the part to synchronization even before having a conflict. Okay. So the next one will be read-write with one-to-many data. Okay, this one will be is recommended for mobile apps with entities that follow a one-to-many relationship and where it's not likely for multiple end users to change the same data while the upload is offline. So what happens in this case is that server has A and B, and they are related, so they are tables with a relation. They send information to the device, and on the device we change both, so both tables, and we send that information back to the server. So the local database changes and sends data with relationships to the server. The data in the server is always overridable. Okay, let's look at, again, here the use case that we have. And what happens here is, if you see now we have a new table, okay? This table is the table friends. And if you remember, Chuck Nolan had a very good friend that was a volleyball called Wilson. And if you look at the data model, you can see that by the cast ID, it's short for castaway ID, the ID is 2, so Wilson is a friend for Chuck Nolan. Now there's a difference between what's in the device and what's in the server. If you see, Robinson is in the 1, but Jack Sparrow is on 2, and in this case, Chuck is on 2. So Jack here is 3. So let's see how are we going to sync this information to the server. First thing we need to do is to check the local data on the primary table for the new, updated, and deleted. So we made this case a little bit more simple, so we won't have many cases. So what happens is that Chuck Nolan is a new one here. Next step will be check the local data on the local data on the foreign table for new, updated, and delete. So if you see Wilson is not from the server, so it means that it was created on the device, he will mark it as a new. So we're going to send information for the server, and we will create the new data, but in this case, just for the primary. So if you look, Chuck Nolan isn't there, and now he is. One of the things is that we need to do is create a dictionary for the primary IDs. If you check, Chuck Nolan here is 3, the ID, but on the local device, he's just 2. So we're going to create a dictionary where this first column is the ID on the device, and the ID here is the ID on the server. So if you see 2, we'll match 3 right now. So next thing what we're going to do is upload the rows received from the device with the new ID from the dictionary. So the friend that was received has a cast ID of 2, and what we're going to look is on the dictionary for the 2 and change that to a 3. So this is very important because this is what's going to maintain the data integrity in the server side. So we're going to add, update, or delete the foreign entity in the server. If you see, Wilson has been created, the ID is 1, but this castaway ID is 3, mapping exactly to Chuck Nolan. It makes sense. Now, both entities will send back to the device to close the loop. What we're going to do is delete first the foreign entities in the device because we need to keep data integrity. If we deleted this first, we would have problems because this has a foreign key. Next, we will delete everything from the primary entity and then put everything that we receive from the server there. And only after that, we're going to put the data in the foreign table that we received from the server. So in the end, you can check that we have Robinson, Jack, and Chuck Nolan with the ID 3, and Wilson also with the ID 3. If you see, everything came now from the server, nothing has been modified, and actually nothing has been deleted, but this shows how we can synchronize information that is related as relationships to the server in an easy way. Okay, so this is the way how we can do it on the OutSystems, and you can look at this. Okay, don't worry about right now. Okay, so in terms of summary, what can we take from this session? That mobile apps need offline support to deliver the best user experience. I think that's pretty obvious, but we should also design offline first. Think about what features or capabilities should be available offline. what data do you need to store in the device database? When should the data be synchronized? And how will we handle this data in the device? If you remember those 3 questions in the beginning of the webinar, what, when, and how, they are very important questions to be answered. So on OutSystems 10, OutSystems 10 makes building offline apps a walk in the park. So if you see, we'll have easy offline data manipulation and some out-of-the-box data synchronization pattern. Again, remember that there's no silver bullet, so you need to know what you need to do in your business in order to implement one solution. Oh, okay, again, there's Wilson. I was thinking that probably we wouldn't see him, but after all, Chuck Nolan, I don't know why you're sad, but Wilson is right here with us. So for the further reading, you can check out some Medium posts made by Ricardo Ferreira, our R&D guy that is expert in this offline subject. And also, I'm sharing with you some links that you can check, and they will provide you a lot more information. So the first link, this one, is a link for the offline pattern sample app available in the OutSystems forts. If not familiar with the forts, take a look and you'll be thrilled with the quantity of components and demo apps that are available there that have been also produced by the OutSystems community. The second one links to the platform documentation where this offline topic is explained. It has a lot of good information about these syncing patterns that we've been looking at. And the last link is to download a plugin that will cipher the data on the device's database. So a plugin is an OutSystems component that uses Cordova plugins to enhance the OutSystems applications with native features. Okay, thank you very much for your attention and for your time.